It says simplifying radicals, and I'm sure you guys already know like how to take a square root of a number when it's a perfect square. Okay, so we're used to that. So I want to give you a little bit of background knowledge first before we move forward. So we're used to seeing like the square root of 100, and everyone knows that square root of 100 is what? Oh, sorry about that. Sorry, my board was frozen. We're used to seeing like the square root of 100, and we say the square root of 100 is 10. Okay, it could also be negative 10. Okay, is that a true statement? Because isn't negative 10 times negative 10 also positive 100? Okay, so what I want to give you is like what the pieces are called. So this number that's under here is called the radicand. Okay, you might want to write that somewhere. Even you can write it on your notes on page 12. That's called the radicand. That's an A. So, because I will say, sometimes I might say we got to simplify the radicand, so you'll know that's the number under the radical. Okay, we know, this part right here. Okay, that's just called your radical sign. And inside of here, even though we don't see a number there, that number, and I'll show you sometimes you do see it, that's called your index. Okay, so when you don't see the number, because there's some things sometimes we don't see the number. I'm not sure why that's there. But anyway, sometimes you don't see it. If you don't see it, just like we don't see the coefficient 1, we know when it's invisible, it's 1. Well, when the index is invisible, and I'm going to put this in yellow because we don't write it, okay, it's a 2. Okay, now, I'm sure you guys have seen like the cube root. So you'll see that. So the index is 3. Okay, but the invisible index is 2. So you can take the cube root of a number. You can also do this. I mean, you can take any root. Okay, let's just say, 125, whatever. You could also, and they don't always have to be perfect. Okay, that's one thing. So like, of course, 100 is perfect. But if I put in a number like, the square root of 56, that's not a perfect square. Okay, so what does the index represent? Okay, let me show you. So the index represents how many times you can multiply the same number together to get the radicand. So this 2 means what same two numbers can you multiply together to get 100? And we know it's 10. What same two numbers can you multiply to get 100? Negative 10 times negative 10. So if I put a 3 here, I'm asking what same three factors can you multiply together to get 8? Okay, that's a question. 2, very good. Okay, so the index is important because it's telling you how many times you're using that number which is the answer, how many times you're multiplying this number to get the radicand. Okay, so let's go back to page 12, and we know this is a perfect square. Okay, right now it's really only asking you for the square root of 16, and it's really only asking you for the positive root of 16, which we know is what? 4. Now let me tell you this, if it's written this way, so write this down, if it's written with a plus or minus in it, that means I want to know, is there a positive? What same two positive numbers can you multiply together? And what same two negative numbers can you multiply together? So you would write it positive and negative 4. Okay, so you want to make sure if you see a plus or minus in it, then that plus or minus carries over to your answer. All right, so this was a perfect square. This is not a perfect square. Okay, however, there's a factor in 28 that is perfect. Now, what do I mean by that? Like, what times what gives you 28? So think of some factors of 28. What times what gives you 28, where one of those numbers is a perfect square? Yes. 4 times 7. So this is how we do this. 4 times 7. Okay. So what we do then, when it's not a perfect square, so this is where your multiplication facts are important. What times what can give you 28, where one of those numbers is a perfect square? Okay. And 4 times 7. We wouldn't want to use other factors because they're not, you wouldn't have a perfect square. So then we would take the square root of 4. What is the square root of 4? 2. And we leave the square root of 7 as the square root of 7 because it's not perfect. So here, when we say simplified in simplified radical form, we're only pulling out the perfect square. If it's not completely perfect, like in number 1, then you find factors to do this. Okay. All right. So let's just say, oh my goodness, my, skills for multiplying may not be perfect because, you can't always think about what's, I know other factors of 28, or let's say you had a larger number. Okay. Your calculator can help you. So let's go to your calculator. And I'm going to show you how you can put in 28 a certain way, and then it will help you come up with that answer. Okay, so let me show you what to do. Okay, so you're going to hit your y equals key, and our radicand was 28, and it was a square root. So we're going to say 28, okay, divided by x squared, and the x squared is because it was the square root. Okay, and then you're going to go to your table, hit second graph. All right, and this is what you're going to be looking for, so I want everybody to pay attention. All right, so you're going to be looking for, we already know this is the answer right here. This is like 2 rad 7. So everything that you see, and we know it's not -2 because it wasn't a -28. Everything that you see after this 2 rad 7, which is the answer, will be decimals. So if you scroll down, everything else after that's decimals. That's how you know you have the correct answer. So look in your calculator where you see whole numbers. Okay, so that's going to be where you see right here, 2 rad, okay, it keeps moving. Hold on, here we go. 2 rad 7. And notice you'll always see 1 in the number. Okay, 1 in the number is going to always be an answer. Okay, just because, 1 is a perfect square, of course, 1 times 28. But 28 is not in its simplest form. So you look for numbers that are whole numbers right here, 2, 7. You'll know you have the right answer because everything after 2, 7 will be decimals. Okay, so we'll do another one so you can get kind of used to it. All right. All right, so let's move on to the next question. So the next one is 96. So first, do you know any factors of 96 before we put it on the calculator? Like that has a perfect square in it that's 96? Anybody? All right, if not, let's put it on a calculator and see. So now we're going to hit the y equals key and put in 96 divided by x squared. Okay. We're going to go to the table. So second graph. Okay, so again, we're not looking for 1 in the number. Okay, and we're really not looking for 2 and 24. Can anybody tell me why? Because doesn't 24 have a perfect square in it? 4, okay. And again, you'll know you got the right answer. If you keep going down, here it is right here. Does 6 have a perfect square in it? No. And everything after this 6 will be decimals. So if you keep scrolling down and you said there are no more whole numbers in this table, that's how you know you have the right answer. So don't get to the first set of whole numbers that you have, Okay, you want to keep scrolling until, I didn't want to stop at 224 because I keep going down. Here's another set of whole numbers. But everything after this set are all decimals. There are no more whole numbers after 4, 6. That's how you know you have the right answer. Okay, so let's go back to our note sheet, and we're going to write this as 4 on the outside. So what's in the first column goes on the outside. What's in the second column goes on the inside. Okay. So really, guys, if I were to work backwards with this, my factors, if I had broken it down like this, my factors would have been 16 times 6. So then you take the square root of 16, which is 4, and you're left with the rad 6. Okay. All right, now the square root of 10. Now 10 doesn't have any perfect factors in it. It's only 1 times 10 and 2 times 5. So this is already in simplest form. Okay, so you just say simplify. Okay, that's already in simplest form. You can't break 10 down any further than 10. Okay, all right, let's move on to question 5. Now, you guys should know what times what gives you 45 that has a perfect square in it without even having to put this on the calculator. Yeah, 9 times 5. Okay, so we'll take care of the exponents in a minute. So what's the square root of 9? 3. So 3 rad 5. Now, I do need to deal with these exponents. Okay. Now, of course, if you didn't know 9 times 5 and you want to put it on a calculator, or you just want to check it on a calculator, you definitely can do that. You would just hit your y equals and put 45 divided by x squared, and you'll see 3 and 5. Okay. Now, when we take perfect squares of exponents, it's different from when we take perfect squares of whole numbers. Okay. So, give you a short lesson on exponents. When we're doing exponents, and let's say I have x to the 4th, y to the 6th, and let's say z to the 7th, okay? And I have it under the radical. So when you're trying to determine when exponents are perfect, okay, remember there's an invisible 2 here, so it has to be divisible by 2. All right, has to be divisible by 2. So if I were doing cube root, it would then, the exponent to be perfect, it would have to be divisible by 3. So that's why that index is important. Okay, so is 4 divisible by 2? Is 6 divisible by 2? Is 7 divisible by 2? No. All right, so you might want to put, okay, for square roots, okay, exponent must be divisible by 2. Okay, that's for square roots. And then, of course, I don't know if that's spelled correctly, but anyway, you guys know what I mean. All right. So anyway, so how do you take it out of the radical like we do the whole numbers? How do you take an exponent out? Well, when it's perfect, you just simply divide it by the index. So you're going to take this invisible 2 and divide it, 4 divided by 2. What is 4 divided by 2? So that goes on the outside. What is 6 divided by 2? There you go. See, that's why that index is important. Okay. Now, but I have to take care of this. This is not perfect. We just said that. Okay. So I'm going to leave it like this. I can't, but it does have a number in it that's perfect. Okay. Let's think. So we got to do it just like we did those numbers, how we broke down the numbers 9 times 5. We can break down the 7. What is the largest even number in 7? Go back 1. 6. Very good. 6 times 1. Remember our exponent rules that you had a test on, you're getting ready to have a test. 6 plus 1 is what? 7. Okay, so we can break down the 7 by making an even number. And really, if you go back one number, that's the highest even number in 7 is 6. So 6 plus 1 is 7. So what do you think I'm going to do now? Divide this by what? 2. Divided by 2, the index. So when I divide 6 divided by 2, what do I get? 3. Very good. And then I leave this underneath because you cannot simplify 1. Okay. All right, so we're going to do another one like this. So you might want to have your spiral out to do another one. Okay, unless you have some room to put it on your note sheet. Okay, let's take another one with just variables. Because variables are different from our numbers. We actually divide them by the index, and they have to be even. Okay, so let's take another one. So let's say I had a to the 8th, b to the 9th, and c to the 5th. And this is all under the radical. Okay, so we know the invisible index is 2. So is 8 a perfect exponent? Yes. Okay, so what is 8 divided by 2? 4. So that's going to go on the outside. So we've taken care of that. Okay, taking care. Oops, I meant to use my eraser, not eraser. All right, so that's gone. So I'm still left with this b to the 9th and c to the 5th. So how can I break down 9? Go back one number. 8 and what? 1. Very good. How can I break down 5? Go back one number. Okay, 4 and 1. All right. So now I'm going to take out the 8 divided by 2. So what is that going to give me? Okay, so b to the 4th. So that's gone. Same thing to the c to the 4th. Divided by 2. What do I get? 2. Very good. So that's gone. So what is left under the radical? The b and the c. Very good. So that's how you deal with the exponents. Okay? It's not hard. You just got to know what to do. I mean, you just got to get those even exponents and divide them by 2 when you take them out. And when we get to cube root, we'll be dividing by 3. All right, let's go back to here. So let's finish this problem. Is y squared already perfect? Yes, it's divisible by 2. So when I take it out, what is 2 divided by 2? 1. So that's going to be 3y. I just took that out. And my radicand is 5x, and that's your final answer. Okay. All right, let's take a look at number 6. And number 6, 16 is perfect. And isn't a squared perfect and b squared perfect? So everything will be taken out, and we will not have anything under the radical. So what's the square root of 16? 4ab. All right, 4. What's the square root of a squared? A. What's the square root of b squared? There you go. You just divide them by 2. Okay. All right, let's do number 7. Okay. And guys, like I said, you can always result to your calculator, but you guys should know some factors of 54 where one number is a perfect square. Give it to me. 9 and 6. Very good. So let's just do that. Okay, because it's okay to think, not just punch buttons all the time. 9 and 6, and then we got the x and y. All right, so what is the square root of 9? 3. Okay, 6 is not perfect. X and y is not perfect because they have exponents of 1, so they will be left under the radical side. Okay. All right, let's do number 8. We can break 45 down to 9 times 5. And is the x squared, y squared perfect? Yes, it is, because it's even. Okay, so what's the square root of 9? 3. That's gone. What's the square root of x squared? X. What's the square root of y squared? y. And what's left under the radical? That's it. Okay, just take it step by step. All right, let's do number 9. Another easy number. What times what gives you 12? That's a perfect square. Huh? 4 and 3. Yeah, we don't want to use 6 and 2 because that's not perfect, right? So 4 and 3. And then we have m squared is perfect, but the p and q will not be. All right, so what's the square root of 4? 2, that's gone. Square root of m squared? M. Everything else stays under the radical sign. What do you think? Easy? Okay. All right, let's do number 10. What times what gives us 8 where one number is a perfect square? 4. So we're going to do 4 times 2. Okay, then we have x squared is perfect, y squared, and you can separate them however you want. Okay. All right, so what's the square root of 4? 2, that's gone. What's the square root of x squared? X. What's the square root of y squared? Y. What's left under the radical? 2z. All right, very good. All right, let's do 32. And again, like I said, you can always put on the calculator if you feel like, your answer isn't right. You can always check. How about 16 times 2? Yes, that gives us 32, right? That's the largest perfect square in 32. I know somebody was probably thinking 8 and 4, but then 8 has a perfect square in it. Okay, so it's actually the largest one is 16 and 2. All right, and then P can stay, Q can stay, and then R squared. All right, so let's do this. What's the square root of 16? 4. And what's the square root of R squared? R, and then we're left with 2PQ. All right. All right, number 12. Is 64 perfect? Yes. What's the square root of 64? What's the square root of x squared? What's the square root of z squared? So what's left? Very good. Excellent. All right, let's move on to the next page. Okay. Now on the next page, so these are the same except for when you get to 17. So notice when you get to 17, there's a number outside of the radical. So whatever you take outside of inside that's here, when you take it out, what do you think you're going to do? Just think about it. What's the invisible operation between this -6 and the radical sign? What do you think? What's the invisible operation? Multiplication. So when you take the square root of 64 out, which is what? What's the square root of 64? All right, so when I take that 8 out, and there is a -6 already there, I'm going to multiply those two together. So what is 8 times -6? All right, -48. That's all you do. So if there's anything outside, you just multiply by what you're taking out. Okay, and x squared is perfect. So what's the square root of x squared? X. Very good. Just divided by the index. Okay, and that's your answer. Everything was perfect under here. Okay. All right, let's look at number 18. Okay. All right, how can we break down the 28? I think that was the first question we did earlier. 4 times what? 7. All right. Okay, so when I take this 4 out, the square root of 4 is 2. I'm going to multiply it by the -2 that's already on the outside. So what is 2 times -2? -4. Okay. Then I'm going to take this out here. So what is p to the 4th? When I take it out, it becomes p to the what? Divided by 2, p to the 2nd, and then I'm just left with the rad 7. All right. Okay, let's do 19. So -6, and then I'm going to break this 54 down to 9 times what? 6. All right. So what's the square root of 9? 3. So when I take this 3 out, I'm going to multiply it by the -6. So what does that give me? -18. And then none of this is perfect, so it stays under the radical. All right. All right, I'm going to do 21, and then we'll be done. Okay, you guys can finish this up later after you've done your other stuff. So 20. What's the perfect square in 20? 5 times what? All right, 5 times 4. Okay, so let's take out all the stuff that's perfect. I'm going to take the square root of 4 out, which is 2. I'm going to multiply it by the 5 that's there. So that's going to give me what? 10. Okay, I'm going to take out the x squared, so that's going to become what when I take it out? X. And y squared would become what? Y. And so what's the radicand? Very good. Okay. All right, you guys did an excellent job. Okay. You do need